Hi everyone, I am Rishana Rinu, Department of Mathematics from E-Content Development Center, Majlis Arts and Science College, Puramannur. Today I am going to discuss LCM and GCD from our third module, Theory of Numbers. Then LCM, Least Common Multiple. You may have heard about LCM. We have already learned it in our lower classes. We can understand what is meant by LCM from its name itself. LCM, Least Common Multiple. If we take two numbers, it may have one or more common multiples. Then the least one among them is the LCM, Least Common Multiple. Definition: the LCM of two positive integers a and b denoted by square bracket ab is the positive integer m satisfying the following conditions. There is two conditions for LCM. First one is a divides m and b divides m. You are familiar with divisibility, which we have studied in the first part of this module. A divides m means m is a multiple of a, and also b divides m means m is a multiple of b. A divides m and b divides m means that is m equal to some k1a and m is equal to some k2b, where k1 and k2 are integers. Then m is a common multiple of a and b. Then second condition, if a divides c and b divides c with c greater than 0, then m less than or equal to c. A divides c and b divides c means c is also a common multiple of a and b. Then m should be less than or equal to c. Then only m will be the LCM of a and b. For example, just take 2 and 3. Multiples of 2 are 2, 4, 6, 8, 10, 12 and etc. And multiples of 3 are 3, 6, 9, 12, 15, 18 etc. Then the common multiples of 2 and 3 are 6, 12, 18 etc. Then the least one among these is the LCM of 2 and 3, that is 6. So LCM of 2 and 3 is 6. It is easy to know LCM of small numbers from its multiples directly, but it is not possible in the case of large numbers. So we need a method. For this method, we want to know prime factorization, which also we have already studied in our lower classes. Prime factorization of a number means write this number as a multiple of powers of primes. For example, 10. 10 is equal to 2 into 5. Here 2 and 5 are primes. So we can write 10 as a multiple of primes. And also another example, 8. 8 is equal to 2 into 4. 4 is not a prime. So we can write 4 is also 2 into 2. Then 8 is equal to 2 into 2 into 2, which is equal to 2 cube. Here 2 is a prime and 3 is its power. So we write 8 as a multiple of power of prime. This is prime factorization of 8. Then there is a general equation for prime factorization. Let's consider an integer a. Then a is equal to p1 raised to a1 into p2 raised to a2 into etc. into pn raised to an, where p1, p2 etc. pn are prime numbers and a1, a2 etc. an are positive integers. Let's move to the method for finding LCM. Let a equal to p1 raised to a1 into p2 raised to a2 into etc. into pn raised to an, and b is equal to p1 raised to b1 into p2 raised to b2 into etc. pn raised to bn. Then LCM of a and b is equal to p1 raised to maximum of a1 and b1 into p2 raised to maximum of a2 and b2 into etc. pn raised to maximum of an and bn. Here maximum of a1 and b1 means the large number among them. So let's move to an example. Find the LCM of 12 and 24. 12 is equal to 2 into 2 into 3, which is equal to 2 square into 3. And 24 is equal to 2 into 2 into 2 into 3, which is equal to 2 cube into 3. 3 means 3 raised to 1. Then LCM of 12 and 24 is equal to 2 raised to maximum of 2 and 3 into 3 raised to maximum of 1 and 1. So, maximum of 2 and 3 is 3. So, 2 raised to 3 and maximum of 1 and 1 is 1. So, 2 raised to 3 into 3 raised to 1, which is equal to 8 into 3, which is equal to 24. So, the LCM of 12 and 24 is 24. So, it is all about LCM. Then we have to move to our next topic, GCD, greatest common divisor. If we take two numbers, it may have one or more common divisors. Then the greatest one among them is the GCD of that two numbers. Definition: let A and B be two positive integers. The GCD of A and B is the positive integer D satisfying the following conditions. Condition number 1, D divides A and D divides B. As we have told in the case of LCM, D divides A means A is a multiple of D, and D divides B means B is a multiple of D. Then D is a common divisor or factor of A and B. Then second condition, if C divides A and C divides B with C greater than 0, then C less than or equal to D. C divides A and C divides B means C is a common divisor of A and B. So, C should be less than or equal to D. Then only D will be the GCD of A and B. For example, GCD of 6 and 12. 6 can be written as 1 into 6 and 2 into 3. So, divisors of 6 are 1, 2, 3 and 6, and 12 can be written as 1 into 12, 2 into 6 and 3 into 4. So, divisors of 12 are 1, 2, 3, 4, 6 and 12. The common divisors of 6 and 12 are 1, 2, 3 and 6. Then the greatest among them is 6. So, GCD of 6 and 12 is 6. In case of GCD also, it is easy to find GCD of small numbers, but it is not possible to find the GCD of large numbers. So, we need a method. This method is also by using prime factorization. Let A equal to P1 raised to A1 into P2 raised to A2 into etc. Pn raised to An, and B is equal to P1 raised to B1 into P2 raised to B2 into etc. Pn raised to Bn, where P1, P2 etc. Pn are prime numbers and Ai's and Bi's are positive integers. Then GCD of A and B is equal to P1 raised to minimum of A1 and B1 into P2 raised to minimum of A2 and B2 into etc. Pn raised to minimum of An and Bn. Here also minimum of A1 and B1 is the smallest number among them. Then we have to go to an example. Find GCD of 12 and 30. Prime factorization of 12. 12 is equal to 2 into 2 into 3, which is equal to 2 square into 3 raised to 1, and 30 is equal to 2 into 3 into 5, which is equal to 2 raised to 1 into 3 raised to 1 into 5 raised to 1. Then GCD of 12 and 30 is equal to 2 raised to minimum of 2 and 1 into 3 raised to minimum of 1 and 1 into 5 raised to minimum of 0 and 1, which is equal to 2 raised to 1 into 3 raised to 1 into 5 raised to 0, which is equal to 2 into 3 is equal to 6. So, GCD of 12 and 30 is equal to 6. It's all about GCD. Then we have a theorem. This theorem relating LCM and GCD. This theorem states that for any two positive integers A and B, LCM of AB is equal to AB divided by GCD of AB. Then its proof. Let the canonical decomposition or prime factorization of A and B. Canonical decomposition means prime factorization. A is equal to P1 raised to A1 into P2 raised to A2 into etc. Pn raised to An, and B is equal to P1 raised to B1 into P2 raised to B2 into etc. Pn raised to Bn. Then GCD of AB is equal to P1 raised to minimum of A1 and B1 into P2 raised to minimum of A2 and B2 into etc. Pn raised to minimum of An Bn. And LCM of AB is equal to P1 raised to maximum of A1 and B1 into P2 raised to maximum of A2 and B2 into etc. Pn raised to maximum of An and Bn. Then we have to multiply GCD and LCM. GCD of AB into LCM of AB is equal to P1 raised to minimum of A1 and B1 into P2 raised to minimum of A2 and B2 into etc. Pn raised to minimum of An and Bn into P1 raised to maximum of A1 B1 into P2 raised to maximum of A2 B2 into etc. Pn raised to maximum of An Bn. We have already learned that A raised to m into A raised to n is equal to A raised to m plus n. We have to apply it in this equation. Then it becomes P1 raised to minimum of A1 and B1 plus maximum of A1 and B1 into P2 raised to minimum of A2 and B2 plus maximum of A2 and B2 into etc. Pn raised to minimum of An Bn plus maximum of An and Bn. We have already told that minimum of A1 and B1 is the small number among them, and the maximum of A1 and B1 is the large number among them. So, if the smallest number is A1, then the large number will be B1. That is, if the minimum is A1, then the maximum will be B1, or if the minimum is A1, then the maximum will be B1. So, we can write P1 raised to minimum of A1 and B1 plus maximum of A1 and B1 as P1 raised to A1 and B1. So, we can write P1 raised to minimum of A1 and B1 plus maximum of A1 and B1 as P1 raised to A1 plus B1. So, we can write the whole equation as P1 raised to A1 plus B1 into P2 raised to A2 plus B2 into etc. into Pn raised to An plus Bn. Then we have to write all A terms together and then B terms. So, P1 raised to A1 into P2 raised to A2 into etc. into Pn raised to An into P1 raised to B1 into P2 raised to B1 into etc. Pn raised to Bn, which is equal to AB. So, we get GCD of A and B into LCM of A and B is equal to AB. Hence, we can write LCM of AB is equal to AB divided by GCD of AB. Hope you all understood today's topic. Thank you.